Finding the area of regular polygons, you'll need to know a few abbreviations that you'll see on the formula chart or when you write your formulas. S is side, A apothem, P perimeter, N number of sides. What you need to remember is this word regular in geometry. Right here, regular means equiangular, equilateral. All sides are equal. All angles are equal. Okay, so we can use this for any polygon. This first example I'm giving you is going 1, 2, 3, 4, 5, 6. It's a hexagon. Okay, and the second one is going to be a pentagon, 5-sided. The formula is 1/2 ASN, where A stands for apothem. Some people pronounce that differently, so if you pronounce it differently, that's fine. S is for side length, and N is for the number of sides. So in this case, a hexagon, our N is going to be 6. That's 6 sides. Okay, again, there is an alternate way to write this. Instead of S times N, you could write a capital P, which stands for perimeter. Okay, the perimeter is the side length times the number of sides. So you're just replacing SN with P. Okay, and that works. Side length times number of side because it's equilateral. Those sides are all equal length. Okay, so either one of those is fine. I'm going to use this first one. Apothem needs to be explained because you probably haven't seen that before. That is the distance from the center of your regular polygon to the side, making a 90-degree angle. Okay, so hopefully this sticks with you. That 90-degree angle has to be present in all of our area formulas. Okay, so this dotted line here is the apothem. Okay, it's to the center of one of the sides and it makes a 90-degree angle. Okay, so here our apothem is given as 2. We have a side length as 6, and you're told that these are regular, so even though it doesn't have tick marks, you're told in the instructions these are regular polygons. So you can assume all of these sides are 6. Okay, and then the number of sides, this is a hexagon, so would also be 6. So I'm going to solve for number 1 here. 1/2 A is 2, that's the apothem. S is the side length, that was given as 6. And in the number of sides, this is a hexagon, so also 6. So we have 1/2 times 2 times 6 times 6. Okay, obviously half of 2 is just 1, times 6 is 6. 6 times 6 is 36. Okay, again, you still need to put your units. Area is squared. This was measured in meters, so 36 meters squared, or square meters. Now the second one's going to be a little more complicated because they don't give you a side length. It's not labeled. They give you this dotted line, which if you notice, these dotted lines in both the examples here are splitting our regular polygons into triangles. Okay, so the pentagon is split into 5 triangles. You can see the hexagon was split into 6 triangles, and those are equilateral. So here I'm going to have to use my apothem and this given length of 7 in this right triangle right here to find this length. And then of course I told you that this apothem comes halfway. It bisects the side. So once we know this length, we can find the full side length. Okay, so right now I'm looking at this triangle and I'm going to find the missing side. So the C that's across from the 90-degree angle is 7. So when I do my Pythagorean theorem, 4 is one of the legs, 7 is the hypotenuse. Should not have put an equal there, excuse me, it's a plus. Okay, you subtract your 16 over and get a squared equals 33, and then you need to take the square root. The square root of 33 is approximately 5.74. Okay, now, again, that is not your full side length. That is halfway to the edge. So we have to double that. So I'm going to multiply by 2. And 5.74 times 2 is approximately 11.48. So that is my S, my side length. So now when I go to solve this, 1/2 times A was labeled for you, that's 4. S I found to be 11.48. And N is the number of sides. This is a pentagon. It is 5 sides. So we have 1/2 times 4 times 11.48 times 5, and you get 114.8. Our units were in inches. Area is squared. So square inches or inches squared.